Week 10, Lesson 6. Okay, so this is on one-to-one and on-to functions. Okay, so let's start off by having you copy these onto your paper. Or if you printed out these notes, you might have them. All right, so then we're going to answer some questions about these pictures. All right, so what I want you to realize is that the one on the left, these are called mapping functions, or mappings. On the left is considered to be the domain, all right, and on the right is considered to be the range. Okay, so just sort of an idea of what that means. Okay, so here's a question. Which of these are functions? And it should be those two, right? Because every element of the domain is paired with one element of the range. All right, that's why this one doesn't work, right? This is paired with two different things. This is paired with two different things. And then there's a whole lot of stuff going on over here. Okay, so then which of these is considered to be one-to-many? And it should be this one. The only reason that this one over here isn't one-to-many is because it's many-to-many. Which of these is considered many-to-one? And I'm hoping you're seeing it's this one, right? We've got many elements of the domain being paired to one over here, right? It's the only one that's many-to-one. So then the question is, which of these is many-to-many? And I think I've already said it. It would be that one. Okay, so now this one's asking you about the inverses, right? So this is where the domain becomes the range and the range becomes the domain. Which of these do you think have an inverse that are functions? And I'm hoping you're seeing it's these two. And again, because of the word inverse right here, you have to consider this to be the domain and this to be the range, right? So you just have to kind of think of it backwards. So now here's the definition of one-to-one. All right, out of these four pictures, only A is considered to be one-to-one. And that's because the original, right, the original where this is the domain and this is the range, that's a function, but also the inverse where this is the domain and this is the range is also a function. That's one-to-one. Okay, so let's go back to stuff that you've known from the past. So this graph that you're looking at, would it be considered a function? And how can you tell? All right, and the answer is yes, and it's because of the vertical line test. No matter what vertical line I draw, it only touches the red line once, right? And I can draw a million of them, but the answer to this question would be yes, and your reason would be vertical line test. So then looking at this green line, is it a function? And of course, the answer is yes, for the same exact reason, right? Yes, vertical line test. All right, new question. Are the red and the green line inverses, and how can you tell? There's a couple different ways. One way is to take a look at some ordered pairs like this one, right? That is 0, 3, and over here this is 3, 0. Those seem to be reflected. This point right here is at -5, -2, but over here we've got -2, -5, right? Those are inverses. Another reason might be the fact that it's reflected over the line y equals x, right? That is a reflection. So again, just be able to explain. Okay, now this is kind of a cool slide. So how can you tell if the inverse of this is a function without graphing the inverse, right? And I know graphing the inverse is actually pretty easy, but if the vertical line test is the test to tell if something is a function, then the horizontal line test is to tell you if the inverse is a function. Okay, so kind of like before, right? When I started drawing all those vertical lines here, if I draw horizontal lines and it only touches the graph once, right? Which again, no matter where I try to draw a horizontal line, it's only going to touch once. That means that the inverse is a function. All right, so take a look at this set of ordered pairs. The question is this one-to-one or many to 1? And the answer okay, so this is considered many to 1 because of the simple reason that this and this and this are represented more than once, right? So 0 goes to 1 and 1 goes to 1 and pi goes to 1, right? There are many things going to one element. Oh, actually, look at that. -1 also goes, -1.5 also goes. Whew. Okay, so take a look at this. Okay, so there's a lot of notation going on here. Okay, let me see if I can read this to you so that it makes sense. This is a set of all the x's such that x is an element of the real numbers, x does not equal 0, and the function of x is 1 over x. Okay, so for me, when I see 1 over x, I know that that looks something like this, okay? Which the original is a function, right? Vertical line test. The inverse is a function, horizontal line test, which makes this 1 to 1. All right, taking a look at this picture. All right, is this 1 to 1 or many to 1? Okay, and again, 1 to 1 just means that the original and the inverse are both functions. This does pass the vertical and horizontal line test, so this is 1 to 1. Oh, sorry about that. There we go. Okay, looking at this, I can tell that it's not going to pass the horizontal line test. All right, in fact, let me draw in that horizontal line where I can tell that it's going to fail, right here. All right, so that means, let me grab a highlighter, this point, and that point make this many to 1, right? If you think about those ordered pairs, as a matter of fact, right? This ordered pair is -4, 0. This ordered pair is 0, 0. This ordered pair is 4, 0. There's many numbers all going to the same one number, many to 1. Okay, so now we need to talk about something that is called on to, okay? On to, which means that every value in the range, okay, in the range, every y value has to have an x value that is mapped onto it. So take a look at this. This is not onto. Okay, this does not qualify as onto because of this one little element right here. That element in the range has nothing mapped onto it. It's not onto. Okay, so for this one, notice it says pretend there's arrows, so let me draw those in right now. There's the arrows. Okay, so this goes up and down forever. And notice it tells you what the domain is and what the range is, all right? The domain is all real numbers. The range is also all real numbers. Okay, so the test of 1 to 1, does it pass both the vertical and the horizontal, which it does, so it is 1 to 1. And then on to, does every element of this range, all right? Every single real number, is there some real number that's going to map onto it? And yes, because it goes on forever up and down. So it is 1 to 1 and onto. So the answer actually to this question then is this right here, both. This is both. Okay, so this one's similar. Again, notice the domain is all real numbers. The range is also all real numbers. So the question is it 1 to 1 onto neither or both? Okay, do you see that it fails the horizontal line test? So it cannot be 1 to 1. Okay, the second that it doesn't pass both, then it cannot be 1 to 1. All right, but is it onto? For every, imagine any single real number that you could ever imagine, 1,000,000, all right, which is way the heck up top. Is there some x value that is going to give you an ordered pair that says some x value 1,000,000? And there is. Okay, so this is onto, just onto, but not 1 to 1. Okay, So this one, again, it's really important that you understand what all this notation means. Okay, the picture is very, very obvious, but check this out. This is a function where x is an element of the real numbers, meaning the domain is all real numbers between -1 and 4. All right, and you can see it, right? This is the smallest value, here's -1, the greatest value is 4. Okay, but we're trying to map onto all real numbers. Okay, so let's ask, is it 1-to-1 just based on this picture? Yes, it passes the vertical and the horizontal line tests, right? It is 1-to-1. Okay, but is it onto? All right, and the key to that is knowing, there we go. The key is knowing, is there a way to get all the real numbers? So like, what about 10? A y value of 10, which is way the heck up here, right? Is there some x value down here that's going to give you a y value of 10? And there isn't, right? The highest y value that I can possibly get appears to be 7. Okay, that's why it's not onto. There's no way to get every single real number. Okay, so now take a look at this one. Again, same picture, same domain. But look what it's mapping onto, right? Now we're mapping onto y values between -8, right? -8 and +7. Now it's 1-to-1 and onto. Okay, again, the notation that's up there is going to make a huge difference. This one is both. It's 1-to-1 and onto, but you got to really, really pay attention to what it's telling you here. Okay, so let's take a look at this one. Okay, now notice it's saying that the domain is all real numbers and the range, or what we're mapping onto, is all real numbers. Okay, so for 1-to-1, it has to pass both the vertical, which it appears to pass, but it does not pass the horizontal, right? You can see that right here. Okay, does not pass horizontal, so it's not 1-to-1. Okay, now is it onto? Okay, so let me ask you this. What maps onto 6? Right? 6 is an element of the real numbers. Is there anything that gives you a y value of 6? Okay, so this one is neither. This is not 1-to-1 and it's not onto. Okay, this one, let's see, I want all real numbers to map onto y values that are greater than -3. Okay, so I'm looking at this graph. It looks like -3 is the smallest y value, and they do keep going forever. Okay, so it is not 1-to-1 because of this, right? Not 1-to-1, but it is onto. Okay, this one is onto.